Okay, Howard, in our last discussion, you mentioned that the equipment owner must set the decision rule and that Transcat's default decision rule is simple acceptance. You also said there are other methods for guard banding that can be used for as the equipment owner's decision rule. Can you elaborate on that a little bit more?
Certainly. So simple acceptance, again, is just reporting the as found data, as left data with measurement uncertainties. Applying those measurement uncertainties to of intolerance or out of tolerance, just reporting that to the client. But that doesn't take advantage of the fact that you have additional information there. And that you can use that to help determine whether or not something is causing measurement risk, what we call measurement risk. So a client can choose a number of different guard band methods as the decision rule. I'll show you an example of what I mean. So this particular example is using a function generator, creating a signal of 100 megahertz, which is right here in the center. There is a tolerance of plus or minus 0.01 megahertz, that's red lines. So normally in a calibration, you're reporting the as found data. Let's say the as found measurement is right here at 100.006 megahertz. You can see that that measurement, whether you're taking a look at the old view that just reported the measurement or the new view that includes the uncertainties, this is just graphically showing you what it looks like. But that's well within the tolerance limits, including looking at the measurement uncertainty to see where it is in respect to those tolerance limits. When a customer chooses a guard band method for a decision rule, then that will set up a new set of what we call acceptance limits inside the normal tolerance limits from the manufacturer. There are different methods that can be chosen that have different formulas that determine where these acceptance limits end up. And when the value is within those acceptance limits from that decision rule, not only in tolerance, where the red lines are shown, but it's also passing the acceptance limit. Now you're going to see two different reports on the statement of compliance on the front of the cert. We'll show that it's in tolerance or out of tolerance. We'll show that it's passing acceptance or failing acceptance. And that's what these limits are here. So in this example, when we look at the ANSI NCSL Z540.3 method 5, it simply takes the, in this case, the uncertainty is 0.0025 megahertz. It subtracts it from the upper limit and adds it to the lower limit to bring in these acceptance limits. That's how that particular guard band method works. So these guard band acceptance limits become the customer's decision rule to say, when you're within those limits, then that is exactly what I need to see. But if it goes beyond those limits, now it's outside of the acceptance limit, it's still within tolerance, and now I have an issue because that can, as you can see here with the measurement certainly being exceeding the upper tolerance limit. It can get complicated, understand. Really what you need to know is that we know these different methods. We present those to each client to say which method is the one that's right for you. That will determine these acceptance limits. When it fails to meet these acceptance limits, we'll identify that to you. We'll also show whether it's in or out of tolerance, as we always have done. And then we're also going to provide a different measure, what we call probability of compliance to the specification, or PCF. And that's really this measurement risk that's shown in red here.
So with that being said, why is guard banding important, and what's the difference between these guard banding methods?
Very good question. So guard banding allows a client to make sure that the measurement uncertainty that variability in the measurement that exists for any measurement does not impact their product measurements, meaning it removes the risk of calling a calibration value intolerance when it actually has a probability of being out of tolerance. Small as it may be, it removes that risk. It eliminates that. It's important to just avoid those areas, to take a more conservative approach and avoid that measurement risk by telling the calibration lab how to account for those measurement uncertainties and what to do with it to apply or pass or fail acceptance. Now, there are many different guard band methods. We've chosen the most common ones to provide to our clients for their decision rule. They can use any of those. I'll show you what those are. So the ANSI NCSL Z540.3 has 6 different methods for guard banding. Method 5 and Method 6 are very commonly used, probably the most popular of those 6 methods. So we're going to offer Method 5 and Method 6 to our clients. Each have different formulas and how they apply the measurement uncertainty. Details on that in our white papers and in the handbook for Z540.3 as well. ILAC P14 is another commonly used one. And that, by the way, ends up being the same formula as Method 5 for Z540.3. Put that in as an option because clients may specifically refer to that document to Z540.3 in their quality system. Another couple of choices come from the ASME B89.7.3.1, and that's actually where simple acceptance comes from. But there is stringent acceptance and relaxed acceptance methods that we're going to offer to clients. So that gives 5 methods for guard banding decision rules. If none of those 5 are what the client wants for their equipment, they can create a customized decision rule. The last 3 here, ILAC P14 and the 2 ASME B89 methods, the client can vary the multiplier that's used in the formula. I'm not going to go into the details, but that's how they can customize what they want for guard banding. In addition to the guard band methods, we also offer PCS, which is Transcat's probability of compliance specification. PCS values indicate the probability that an instrument's value is correctly being stated as intolerance or as out of tolerance. So you get probability of false accept or probability of false reject. And I showed that graphically previously how that looks with the green and red on the uncertainty distribution compared to the tolerance limit. Incidentally, probability of false acceptance is 100% PCS value. May be useful. But we have white papers on this on our website.
Okay, so that's a lot of information to take in for somebody who's completely unaware of all these changes and options. How does an equipment owner figure out what service level is needed, let alone what guard band method to use for their decision rule?
It all starts with their quality policy. If they require NIST traceability, they will have to have measurement uncertainties and automatically go to an accredited calibration that provides those measurement uncertainties. If their requirement is to use an accredited lab, then the question becomes, just need an accredited lab for trust and confidence in the measurements, or do you actually need the accredited calibration that provides the measurement uncertainty? So something our client will have to decide, but we'll need to help them look at that and see what's important. It gets down to where the instruments are being used, or the processes being measured, or the product. What type of product are you making? If you're making toys for children, that those are safe. But there may not be requirements for measurement uncertainty for application to the product. If you're manufacturing, taking crude oil and making, gasoline or diesel or a number of products there, again, safety is a very high concern for those processes. And the quality of the product is also important. So accreditation may be important for those types of industry. Certainly, if you're in aerospace and you're making airplanes or any of the components that go on aircraft, or in automotive for safety, or if you're in medical device manufacturing for implantable medical devices, pacemakers, stents, spine parts, critical tolerances are involved there. And so you probably want to minimize your consumer risk the clients that you sell these products to. And so accreditation becomes very important in those cases.
Okay, great. Well, thank you for taking the time, Howard. Again, if you have any other questions, our website is full of white papers and materials available to explain this further, or you can feel free to, again, reach out to us either via the contact us form on our website or give us a call at our 800 number, and we'll be happy to have one of our calibration specialists get with you and provide additional information and help you navigate these choices. And again, thank you for your business. We value you as our customer.
Thanks for having me, Roman. I appreciate answering these questions that are very common to our clients.